Hello all, welcome to the second session of week 2 of microservices using Java and Docker. So now let's try to understand what is the comparison between traditional and cloud native application. In the previous session demo, we just saw how the application development and infrastructure evolved over time. So now let's build on that discussion. So traditional applications are basically less agile, dependent on infrastructure, less frequently updated, and generally more resource intensive to develop, test, and maintain. So in the last discussion or demo, we saw that traditional applications generally follow the waterfall model, and they are kind of monolithic in nature and architecture, and they are usually deployed or packaged in physical server, and they just exist in the data center. So due to that, the issue is they are very less agile, meaning they can't adapt, or if there is any change in requirement. So what happens is in traditional application or in the waterfall world, what happens is once your requirement is given by the customer and you start the application development, there is no scope for you to change the requirement midway. Okay, so that is the kind of principle in waterfall where you freeze your requirement before the application development starts. But what happens in real world is in the agile world or even in the real world, what happens is the requirement are quite fluid. I'll give you a simple example. So say assume that you wanted to build a food ordering application, right? And you decided that you're going to allow your customers to book food from the nearby restaurants. But over the time you also see that there is demand from the customer to also kind of order groceries or have some delivery mechanism where they can quickly send certain items to their friends or relatives who are living nearby. So if you want to also add those kind of functionalities in a traditional water cycle, that is not possible until you create the entire application and again go back to the requirement gathering phase. Whereas in Agile, since we are just breaking down the application into small chunks and iterating over time, it is quite easy for us to implement all these changes in the next cycle or the next iteration. And if you just contrast that with cloud native application, so by principle we can say the cloud native application is agile, independent of underlying infrastructure. It is frequently updated, more secure, and good at managing resources efficiently. So as we saw in the demo of the last session, we saw that agile, once the evolution happened of the software development world, we slowly moved from this waterfall mechanism to agile and DevOps. So what happened is, since it is agile now, being agile, the advantages you can quickly develop your application in bits and pieces, like in small chunks of minimal viable product or iterations. And as I gave you the example of transport, you start first with a bicycle, then upgrade it to a bike, then upgrade it to a car, and then make it a super luxury car, and so on and so forth. So using the same concept, the agile works on the customer feedback. So you just develop a quick working software prototype, get the feedback from the customer, and keep on improving it. The second point, we also saw that it is independent of underlying infrastructure. So as we saw that instead of directly deploying our application on the physical server or virtual servers, we are now shipping our microservices as part of containers, which is getting deployed into cloud. So the cloud vendors are the person who are going to manage all these physical hardwares and data centers for us. We don't have to worry anything about it. So in simple word, if tomorrow you get a startup idea and you want to kind of develop your own application, so you don't have to really bother about what is going to be my server or where I'm going to keep my server, how I'm going to host it, and all that stuff. All you need is a subscription from any of the cloud vendors like Azure or Google or AWS, depending on who you like. And once you have it and the pipeline set up, you can directly deploy and get your application up and running in no time. The third is it is frequently updated. So as we saw even in the previous demo discussion, that any application these days that you use frequently, it could be Google, Facebook, it could be Uber, Ola, Swiggy, Zomato, whatever it may be. So all these are kind of frequently updated. There are tens and thousands of deployments that are running every day in the backend. And your application is frequently updated just to ensure that you get the latest updates, all the security vulnerabilities are fixed, any bugs that are reported that are fixed, any new features that are required are added, so on and so forth. And why that is possible, again it goes back to this agile principle. Since we have modular teams, we have small iterations, it is easy for us to kind of deliver frequent updates. And also it is more secure. Why it is more secure? because since you are developing a cloud native application following all the modern best practices, you are creating modular classes or components. You aren't mixing too many logic in one class, and also you're keeping them securely in a container which gets deployed in this specific tenant in the cloud, so it makes your application more secure. And finally, we also see that it is good at managing resources efficiently. And why that is the case? Because unlike the earlier software development life cycles or principles, wherein you just had one application which used to run in the physical server and consume all the resources, here the concept is you just develop modular services, each of which is now running in its own container, which is again deployed in cloud. So what happens is if you just take a real world example, I'll just give you a real world example. So assume that you have created an application or microservice application or a cloud native application and you are deployed in the cloud. So normally how these cloud vendors charge you is they charge you for the time that particular container is up. So say for example, I have developed say maybe a clone of IRCTC, or you assume that I have created a travel book agency like makemytrip.com. So what happens is assume I have now 10 instances of my application running. So what the cloud vendor will charge me is for the time these 10 instances are up, or these 10 servers, the server instances are up, right? And in case in the future, there is less demand on my server. So say I am it's a non-peak season, or there's some COVID related lockdown that came in. So I don't really require 10 instances of my server running to handle all the server load. I can just have maybe 1 or 2 servers running, which can handle the minimal load that is coming. So in that case, what happens is the 8 of my servers will be just shut down, and the cloud vendor is not going to charge me for those 8 instances. Similarly, vice versa, assume that there's a summer vacation coming up, and there's quite a load on my application. So instead of having 10 instances, I could have 100 instances running. And what happens is dynamically, since I have 100 instances running, the cloud vendor will charge me for the 100 instances running time which is coming for that particular month. So that the advantage of that is we can manage the resource efficiently. We don't have to keep the server running up all the time. We don't have to keep it off at all the time. So based on the load, we can dynamically adjust it. So now let's get into a quick demo and understand how this traditional and cloud native application works. So we just again come back to the same evolution that we saw in the last demo. So just to a quick recap for you, as we just saw. So right from this waterfall model till this DevOps model, we have kind of evolved iteratively over the time. And as you can see, the underlying architecture and the way we design it is what determines the entire ecosystem. So if you see in the waterfall model, as I said, the requirements are really kind of frozen before the development starts, and that's the reason what happens is you also had this architecture like Monolithic, where we packaged all these components together as one single component, and then we kind of deployed into a physical server, and then we had the data center which kind of hosted all these physical servers. And as the time evolved, what happened is we realized deploying a application directly into physical server is not really efficient or cost friendly. So that is why we invented this concept of virtual machines, wherein we had one large physical server inside which we created a lot of virtual machines inside which our applications were deployed, right? And here we also had this concept of hosted. So instead of having our own data centers, we could also kind of lease or take on rent physical servers from any third-party vendors and have the virtual machines inside it for us. And finally, this got evolved into the cloud, wherein we had this third-party vendors like Amazon, Google, who gave us this infrastructure, and all we needed to do was just create our application and create pipelines which would directly deploy our application into them. So before going any further, now let's just try to understand quickly, since we have been talking a lot about cloud native application, okay? So I just want to quickly kind of summarize the benefits of cloud native applications. So it kind of becomes clear to you what is the advantage or what is the end result of doing all this, why we create microservices, containers, backing services and all this stuff. So what is the end result of it? So the first thing that we get is resiliency, as we saw, right? So what do we mean by resiliency is it can't stay online at all times. Okay, so it means that, as I gave you the example, so even if the traffic is less, the traffic is more, your application should be up and running at all time. That means it is resilient, right? So that is the meaning of resilient. The second thing we saw is the advantage of having cloud native application is it's quite independent. So what do you mean by independent is since we are creating different modules or say different services, right? So it can be possible that each of the services can be created with its own architecture or underlying technology. So say for example, this service I could create with Java, this service I could create with .NET, this service I could create with Python, and even the database could be different. For example, I could use MySQL. Here I could use NoSQL. Here I could use something like a GraphQL, so on and so forth. So the concept is I could mix and match multiple technologies to create my different services. At the end of the day, I could still ship all of them together as a microservice because the interaction between them is minimal or zero. This is quite independent, it runs on its own. This is independent, runs on its own. This is independent, runs on its own. And also all of these follow a common API pattern, which means that they expose certain APIs and they expect to have that contract between them, where they expect the request to be in certain format and they will give the response in certain format, mostly in a JSON format, right, which is object key value object pair. So that is the reason what happens is your cloud native is quite independent. So it doesn't really have to have a tight binding between multiple services or worry about technologies. So what used to happen in the previous days is, so say example, if you are a large organization, so say maybe say you are a organization as large as say Facebook. What used to happen is if you decided at the enterprise level that we are going to go with Java or .NET or Python or C or whatever, it becomes important that all your departments are following the same technology. So if tomorrow some new technology comes in, again at the enterprise level, you have to do that direction change and rewrite or do all that stuff. Else what happens is, because before the microservices era, we didn't really had this independence, or before this REST concepts came into play, we really didn't have the standard concepts of you give me this request and I'll give you this response. So that all those concepts only started when the SOA was initially implemented. So that's where this this concept of decoupling first came into picture. And once the microservice came, these concepts really stuck along, right? So this was the second advantage. The third advantage is it became quite manageable to have all the services here. So what that means is, since we had automation in place, we had concepts like DevOps and all that stuff, it became very easy for us to manage our application. If you want to do a deployment, all you need to do is just commit your code and the deployment just happened in the background using the CI/CD pipeline, right? If you wanted to test your code for quality, once you committed your code, automatically the unit test cases, all that unit testing and all that stuff, the quality linting and all that things can be run in the background automatically. So the advantage is you just focused only on the application core functionality. The rest of the part became easily manageable because you had the necessary automation in the place, right? And the third is, it also became kind of observable. So what you mean by observable is, so in the earlier days when we had the applications I'm talking before the microservices and cloud and all this stuff. So usually what used to happen is, there used to be an application, you deployed it in a server, and again in that server you used to have a ton of monitoring software which again gave you certain data with which you developed a dashboard and you used to see the running status of all the application and the servers which are doing, right? So this involved certain manual efforts. But now, thanks to the cloud native application, what happened is all this stuff became quite easy, because since you're using vendor, you're using third-party vendors like Google, Amazon and all that stuff. Once you deploy your application in these cloud server premises, what happens is they by themselves kind of give you or expose you certain APIs and dashboard, through which it becomes easy for you to quickly monitor what is your application load, which server is performing well, which instance is not performing well, and what is the load, throughput and all that stuff. So it becomes quite easy for us to observe what the application is doing, what is the real-time status, so on and so forth. So this is the kind of the advantage which cloud native application provides us. And before we end, I also want to quickly just give a conceptual overview of how can we get into a cloud native application mode. So this is just for your understanding. It's not related to the course, but I felt this will be a better way for you to understand how can we really adopt cloud native concepts, right? So there are basically kind of 4 stages how you develop any cloud native application. Okay. The first stage is you adopt the principles of cloud native. That is the first stage. The second stage is you actually build and develop. So once the second step is you build and develop your application. The third is you deploy the application. And the final step is you operate, right? Or rather you can say you maintain it. Okay. So these are the 4 major steps on how you create a cloud native application. Okay. So let's quickly see one by one what we mean. Okay. So just have this in mind. So whenever you want to get into the concept of creating, so this can also be an important interview question for you. So if someone asks you, okay, you say a lot about cloud native application. Can you tell me if I have to implement cloud native application, what are the steps for it? So you can say that, there are 4 basic concepts or basic steps. So first is you have to first adopt the principles of cloud native application. Using that principles, you develop and build your application. Once you have built and developed your application, you go ahead and deploy it. And once you deploy it, you maintain or operate it. And what we will also see now, what goes inside each of these steps. So the first step that we saw is the adopt part, right? So in adopt part, basically what happens is we have to first get into the concept of the cloud native mindset, right? So the first thing is, since it is a cloud, right? So what we basically do is we need to have a cloud account, right? So basically we need to have a cloud account in place where we can use the infrastructure for us to create it. The next, we have to ensure that we follow this API concept wherein any services that we are going to create is going to follow the API pattern wherein it will accept request in a certain pattern and it will give the response in a certain pattern, right? So we have to follow that. The next concept is we will be having certain architecture principles in place, which is basically the microservice architecture. So wherein we would be creating the application architecture and all that stuff. And also we would also follow the modern design best practices. Like we would keep it modular, we would have it only do one class do one function at a time, so on and so forth. We won't unnecessarily repeat the code and all that stuff. So this is the first phase where we kind of first adopt the cloud native part and we get into the mindset. Obviously we will also have the agile methodology and also the DevOps lifecycle in the place, right? So this is the first part. In the second part, which is the actual build or develop part, right? So this is a part where we actually kind of going to implement our API designs. So whatever designs we have created earlier, we are going to implement it, right? And along with that, we will also have the other parts of the application which gets built. We will have this DevOps setup, pipeline setup in place, right? So in the adopt phase, we only just decided that we will be getting into the the DevOps and all that stuff. So this is the phase where we actually are going to implement it, right? And along with that, any of the SDK, software development kit, or CLI, command line interface, or any of those stuff which will be required for you to develop and create your application will be used over here. And finally, we'll also be using some of the cloud services or concepts which will be implemented. As we saw, backing services are provided by the cloud vendors. So if there are certain services which we need to use, analytics or monitoring, message brokers, so we'll also be using the cloud managed services over in this phase, right? So this was about the build and develop phase. The third phase, the third step is we deploy it. So deploy, as we saw that, it is going to be deployed in the cloud. And since we are going to use microservices, majorly what we will be concerned is the first is the API gateway. So what is the API gateway basically is, so in a real world, what happens is when I expose my service, right? Just understand that, whenever you expose your service, internally your service would be mapped to a particular port, and, it will be like, having its own, name and all that stuff. But when you expose it to a real world or a third party world, you will be just exposing it in a simple name. So say something like, I'm just giving an example, bank.in/accounts. Okay. So what happens is internally, when this bank.in request comes to your server, it will first get into the API gateway. Your API gateway will have a mapping. So it will first check out that, what is the server or the service that is actually hosting this bank.in/account. So then from this registry, it will find out that, there is a server container which is running at port maybe 8081, and it is exposing this bank account. So what it will do is, it will take that request, take it to the container or the server which is running on the port 8081 accounts API, and forward the service, right? And similarly, we will also have functions in the deployment step. So what is functions is nothing but, you can just say these are certain I would say functionalities or certain activities which are carried out during the deployment process. Probably it could be like converting the packages, or transpiling the code, so on and so forth. And then you would have something like, your Docker container, or basically the orchestration part. So what is the orchestration part is the way all your containers are now deployed into the server and how they are managed. So that part is called as the orchestration. And usually to do this, we have certain tool like Kubernetes. We also have a section on Kubernetes down the line. So you'll understand how you kind of manage your entire application using Kubernetes, right? And finally, you also have concept like service mesh. So service mesh, as the name suggests, is nothing but it's just a mesh, or you can say a grid of different services which are running, or which will be used for your deployment of your application, right? So basically, why we use service meshes to enable service to service communication, right? It is a infrastructure concept. And finally, we saw that we have the step of operate or maintain. So what the operate or maintain step does is, as the name suggests, it is once your application is deployed. So we are here, from here we kind of maintain our application. So here the concepts that you implement are you implement the monitoring part, which is a backing service, right? You do logging. So you want to check how your application is doing. So you use logging. Then you have analytics, right? Probably you would have periodic email alerts. So say if you want to notify your end users or your administrators that something is up, down and all that, you'll be doing that. And after that, you'd also have something like maybe security services or security stuff, patching and all that stuff. So if there is certain security patches which has to be updated or all that stuff, you'll be doing over here. And also you'll be monitoring the events in your application, so on and so forth. So this is the operate part. So with that, I hope you guys understood that how we can adopt the cloud native application concepts and implement our own application. So what we are going to do is basically I'll just give you a quick overview of what we are going to do in our course. So in our course, as I said, the focus is on creating the microservices, right? So microservices is nothing but it is just a API, right? Which will expect certain request and it will give you certain response. Okay, we are not concerned with the front end part, the UI part, and we are also not concerned with the back end part with regards to this course. Why? Because these itself are a course on their own, they will take a lot of time to create and understand. But rather what we are more under focused is our concern to understand is interested to understand rather, I would say, is the API part, wherein we will understand how can we create this API to specification, how can we interface it with the backend, and how can we expose the responses which can be then used by UI, so on and so forth. Okay. And in order to create this microservices, we would be using all these concepts that we have seen so far. So say for example, first we'll create a basic microservice, then we will migrate it into a Docker image. Then we will then take it into a Kubernetes. Then we will also try kind of use certain Docker related commands like Docker compose, build packs and all that stuff to automate the build image and configuration and all that stuff. And finally, at the end of the course, we also have a short introduction into the UI part, wherein we'll create a UI layer of the application using the Spring MVC and connect it with the database and create a sample application, right? And for the purpose of microservices, we'll be focusing on a bank application, wherein we'll try to understand how can we create a simple bank application. So that will be part of the week 3 discussion. So with that, we have come to the end of this comparison between the traditional and cloud native application. See you in the next session. Bye.